Okay. All right. So in order to determine if the conclusion follows logically from the premises, we are going to first translate our premises, the statements that are premises, and the statement of the conclusion. And another way that we have to approach this is by drawing the diagrams, but the current statements are not quantified statements. So we can do the translation way. Okay, so the first premise, squares have 4 sides. Now, in order to figure out what kind of a connective to use, another way of making that same statement, we can rephrase this by saying if it's a square, then it has 4 sides. Okay. And so then the first premise can be translated into a conditional where it's a square. It's the first simple statement. It's statement P. It has 4 sides. It's another statement Q. And so it's a conditional relationship between them. So if it's a square, then it has 4 sides. Now the next premise is my yard has 4 sides. So essentially, even though it's specifically talking about a yard, it essentially repeating the same statement that Q says. So it has 4 sides. My yard has those 4 sides. Essentially, I'm just repeating Q. All right, and then conclusion is my yard has the shape of a square. So again, we're just replacing it has and it is with my yard. And so then it's therefore P. So if it's a P, then it's a Q. If it's a square, and then it has 4 sides. It is a Q, so my yard has 4 sides, therefore it is P, therefore it's a square. Now, is this a logical conclusion to make? Well, is everything that has 4 sides necessarily a square? Well, no. So just because my yard has 4 sides, it doesn't necessarily make it a square. It could be just something super irregular. So no, this is not a valid conclusion. Now, the way to make it more systematic is if you refer to the valid, invalid forms. This will go away. Yeah. Anyways, if P, then Q, Q, therefore P. If I look at our valid, invalid argument forms, I can see that the very first invalid form, if P then Q, Q therefore P, is a form of an invalid argument. So it is an invalid argument because it matches this form, which is a fallacy of converse. But ultimately, our answer is that it is invalid.